EE271 Signal Processing Lab Group E3. Members of this group include Kelsey Finlay, Goodwin, Jack Galliford and George Foster. The objective of this lab was for the group to construct a transmitter circuit for triggering an ultrasonic pulse, followed by a receiver circuit to condition the received ultrasonic pulse. The circuit was constructed in software and hardware. The purpose of this lab was to measure the thickness of a steel block and by doing so detect any defaults which occurred within the steel.
For the transmitter circuit, the hex inverter design was used. The transmitter pulse works due to a differentiator, creating an impulse within its high-pass filter. The germanium diode is then used as it activates at low voltages which are being used within the transmitter circuit to activate the impulse signal. Most of the NOT gates within the circuit will be used to correct the polarity of the impulse signal to keep it positive. The final two will be used to create a delay which resets the counter before the next impulse signal is fired. The values of the components were chosen to create a period longer than one created if sound was to travel through 1 meter of steel, and a reasonable frequency for the transmitter was then generated from this. On screen now is the resulting impulse from the oscilloscope measurement. As can be seen on the screen, it is very similar to the PSPICE results that were shown previously. The differences will be small, but will be deemed down to uncertainties or errors that will come mainly from the equipment, like the oscilloscope.
The purpose of the receiver circuit is to collect the output signal from the rest of the circuit and amplify the wave's current and voltage. It will then rectify the wave. Once this has been done, the signal is passed into a comparator. The purpose of the comparator is to turn the sinusoidal wave into a square wave by using a threshold voltage. This is done by comparing the input voltage to the threshold voltage, and if it is greater than the threshold, it will be considered a high signal. If it is less than the threshold, it will be considered a low signal. This gives the desired square wave.
The general overview of the circuit is that the transmitter will fire a signal into the steel block and the JK flip-flop to start the counter. Once the signal returns and passes through the receiver, the counter will stop. Using a time-to-space converter, the depth of the block was calculated and displayed onto the screen. From the hardware-tested simulations, it was concluded that although many values had to change, the circuit's theory and design was producing the outputs which was expected. Thanks for watching.